so let's take a look at this Go stuff. By the way, I'm working on a lot of master boot record stuff and boot kits and rootkits, and I should have that for you by next week. I have the early versions of that in 126, but that's not ready yet. And what is ready is Go. So I would show it to you if I could only reach the top of my browser, which the Kahoot thing is in the way. All right, there we are. So, all right, so let's do some of this stuff. Right here, Go the wrong way, it's worth extra credit in all my classes. And you do this on any machine you want, in principle, but I've only done it on Linux, so I would recommend using Linux. I think I'll get rid of this. I was going to demonstrate that TCP multiplication stuff, but it's not worth it. All right, so here's, I'm just going to use a Debian Linux machine, and you could use anything you want. And here in the project, let's see if I can find the right browser. Okay, here, in order to install it, you just put on curl, if you don't have curl, and then you just curl something and run it. This will fetch the Go package. This, check the SHA sum to make sure it's accurate. And then you just run a script and that puts Go on your machine. Now, when I've done Python, you just make a file and run it in Python. That was the old simple language. It's an interpreted language. It doesn't matter where you are. Go is a more complicated language. The point of Go is you have to have structure to your programs. So you don't just put your program in any old folder and run them from anywhere. Let's see a chat message coming in. Not on record. How do I find this? It is recorded. All right. You go to my home page, which is here, and you find it right at the top. Go the wrong way. That's where we are. All right. So the anyway, so these commands here are how you typically make a Go piece of software. And it is more like real enterprise software development than just writing a Python script. So if you execute these commands, you make a directory and you're called work. And then inside work, you make a source, my project hello. And this is the correct structure for modern modular programming. And then you have to put it in the right folder. Go will expect this folder structure and you have to get used to it. So now my source code is in source my project. The name of the app is in the folder name and in the file name, and you have to have it right or Go will not find it. And this is true of most modern programming languages. So now here's where you put your code, and this is the simplest code that just does hello world, how you always want to get started. And so let's take a look at this code. This is very much like C. Remember, in C, or for that matter, Python, you have to import libraries for everything you do. And if you want to do a print, that's in the format library. In C, it would have been standard io.h. And so you have to import the format library. Everything has to be a package. And this first package is called main, just like main in C. And format printf is what will print this line. And this is a format string. This is like C's printf that we've used before. It has this format string with the \n. So that's just a hello world. So that's the source code, but you can't just run the source code the way you can in an interpreted language. You have to compile it. But compiling it is incredibly simple. It's go install my project hello. And that will install it so you can run it from the command line from any folder. So you install it like apt-get install, but that's compiling it with the Go compiler. And now you can run hello. What's that? Input ls?
ls. This was in the directory.
I can do an ls if you like, and all you're going to find is a directory called work. And everything's in there. But if you do ls work, then you'll see bin and source. And so you put your source in the source folder and the binaries go in the bin folder. Yeah, work. If you do work source, I'm glad you do this, then there's my project. And if you go in there, that's where hello is. And there's going to be a different folder for every project. And if you look in there, that's where you have the structure of, that's where you have the source code. And when you compile it, it's going to go way back up here into work bin. And this is the way it works. So you've got a binary folder with the compiled stuff, and you got a source folder several folders down, and you have to have all this structure just right, or it won't work. So that is a little more complicated, but you get used to it. Let's got a couple chat messages. Run a Windows 10 machine on Google Cloud I have no idea how to do that. I think that's a problem with licensing, absolutely. As far as I know, and we don't have any free Windows 10 stuff for students anymore. We could not get Microsoft to give what we paid for them. But there is an evaluation version of Windows 10 someplace, and you could try putting that in the cloud, but I don't know if it's going to work. It's a good question. I have no idea how to get Windows 10 in the cloud. That's why I use Server for everything. There may be some way, but I don't think any cloud provider gives it to you. You could try Azure, and I think you'll find the same thing. You only get servers on Azure. I don't think you get Windows 10 on Azure. I think this is a Microsoft licensing issue, and I don't have a good solution, but I'm not an expert. There may be other people that want to do that. Anyway, that's a good question. Anyway, so there's the structure, and let's see, there's, okay, great. Yeah, right. Anyway, for people who actually want Windows 10, and of course, why would you want Windows 10 in the cloud? You want Windows 10 on your desktop. That's why I think Microsoft doesn't really support it. Putting a desktop operating system in the cloud is a little screwy, but it would be nice to test things. Anyway, so that's just Hello World. So let's, if I can find my right browser. All right, so let's make a port scanner. I'm going to call this port scan 1. So I have to start with this stuff. Let's see if I can get some of this garbage to go out of my way. Is there any way to make this thing smaller? Over here, okay, good. All right, and how about making this stuff smaller? All right, now I might be able to be more efficient. Got too many windows open, and when I project, my resolution goes down, so it gets harder to control my machine. All right, so if I do this, now I've made a directory, work source my project portscan1, and now I'm going to edit a file in the portscan1 folder, in the source folder, called portscan1.go. And here's what you have to do to make a port scanner. So we get rid of the colors so we can see it. All right, you have to import net, format, and string convert. And then, and notice, by the way, that carriage returns can separate items. So it's not true that white space doesn't mean anything. It's not like Python, where the white space has to be just right or it won't understand loops. But carriage returns can delimit items. Anyway, now I have a loop, which looks a little bit weird. One thing I really ought to mention is this colon here. That is a specific thing to Go. The way Go works, if it was C, you would have to define your variables and say integer I someplace, and it wouldn't let you use it without defining it. If it was Python or JavaScript, it would guess what you mean. So if you said I equals 1, it would guess it's an integer. If you said I equals 1.2, it would guess it's float, and sometimes it'll guess wrong. You can use Go in that mode, but if you do, you have to use a colon the first time you use. Colon means define a new variable called I and assign it to this value. After that, if you compare it to something, you don't use the colon anymore. I less than this, I plus plus. And this is the loop structure. Notice how there's no parentheses around this stuff. And then there's curly braces around the loop. So it's a little bit like a C loop, but a little bit weird. And you get used to this colon stuff. And by the way, if you try to use a colon a second time on the same variable, you'll get an error. It says not a new thing on the left of the colon. So anyway, then you have, here again, connection is something you'd see in Python. There's this command called netdial, which is a network library command which connects to a server. Dial is kind of a hilarious thing to call it, but that's what they call making a TCP connection. So I connect with TCP to my local machine with a colon and the port number there. So that will try to do it. And this command has two parameters that come back, a connection handle and an error. So you do it this way, two things come back newly defined when you do that. And now if error is not nil, then print port is open, and you could say else print out the error was, but we didn't bother here. So the only thing this does is try to connect, and if there's no error, it tells you the port is open, and that's the only response. So let's run this one. One thing that surprised me is it's doing all 65,000 ports, which takes about 10 minutes with Nmap, but this is local host, so it's plenty fast. So now I have to compile it and run it. So I have to install it and then run it. And now when I run it, port 22, there's other things open because I installed some other software for the CTF I was doing over the weekend. And it's not done yet, but it's made it 6,000, so it'll be done pretty soon. Anyway. Yes. This is doing localhost, that's why it's so fast. If I did it over the network, it would take a lot longer. And all right. And so then the next thing is, if you do connect, we'd probably like to get more information. So let's make a banner grab. So this is going to be port scan 2. Again, I have made a lot of mistakes when I was starting. Every time you change a name, you have to change the name here and change the name here and change the name here. And I must forget that like 2 times out of 3, where I would make my new program in the folder with the old program, and then it won't compile. So you have to have the folder name match the name here and the name there, or it won't work. Anyway, that takes a little work to get used to. And I suppose there are development environments that would do it for you, but I only know how to do it this way because I like to do everything very simple and command line only, because that's often the case when you're hacking into machines. You have a limited environment, so I just like to stick to the simple way. So here is the upgrade of this thing to fetch the banner. So what it does, if I can get my mouse to scroll up, all right, you import the same things, then you have your loop. I'm going to go from 20 to 24. That's all, just a small group of ports. Now I'm going to do one of my target servers on the internet, target.bounceconsulting.com, and now I'm going to scan it and connect to those ports. And now when I connect, if there's no error, it's going to print that it's open, and now it's going to define a buffer. This is how you define a slice. I have no idea. They don't call these things, in Python they call them lists, in C they call them arrays, and for some ungodly reason in Go they call them slices. A slice is a bunch of data. I have no idea why that term is there. There's probably some brilliant reason for it. So make, what's that?
Like a link.
I would think it seems to be the same thing as what I would call an array or a list. I'm sure there is some subtle reason with the memory structure why they call it a slice. Anyway, so this makes a bunch of byte variables, 1,024 of them. So this makes what I would think of as an array, although the technical term is slice, that has 1024 places to put data, and the data you put in there is bytes. There are various kinds of data. There's integers, 8 bits, 16 bits, 32 and 64 bits. If you don't define it, it defaults to 64-bit integers, but you can make byte integers, and then they're just 8 bits, and that's, of course, what you want if you're just trying to store ASCII characters. So that's what they did. Now I read the bytes from the buffer, and then I just print, and I use buffer from 0 to the number of bytes read, and then I print it with a %s format. So if it's ASCII characters, it will print and be readable. So that's what's going on here. And this is good stuff to see. You also notice the colons here where you define a new variable. So those are a few formatting things to notice. And by the way, if error equals nil, we still didn't print anything if the error was not nil, I think. Anyway, let's run this one. That's port scan 2. So I have to compile it the same way with go install my project port scan 2, and then run it with port scan 2. And now it connects. So it goes 20 and 21 are not answering, so it just does nothing. 22 is open, so it fetches the banner. 23 and 24 are not listening, so it runs this for. So that's fine. But what would happen if I went further? Let's just modify the same file. If I go back to here and I try going up to, say, 30, let me get rid of the colors to make it easier to see. So if I wanted to go from 20 to 30, all right, I'm going to save it. And now I just compile it again. Okay. Now it goes up to 24 and just freezes. It's never getting anywhere. So something bad happened. And this is because port 25 is open, but it doesn't have a banner. That's SMTP. It's open on my server, but it doesn't reply to a handshake. You need to send it a formatted request, like an HELO command. So it's waiting for a banner that's never coming, and this is going to have a long timeout. So I stop it with Control-C, and now this means I have to figure out how to implement timeouts. So let's move on to port scan 4 and show you how to put in timeouts. So you go here, the same old jazz, you make a new folder for port scan 4, and you make a new file called portscan4.go in there, and then you put in this code, and this code is going to go from 20 to 30. It's going to make the port here, and it's going to call into that port. And then when it does the connection here, this is, let me go to the end of this command to show you the new stuff. Here is the new stuff. It now connects to the URL, colon the port, and then it has another parameter, 1 times in second. This is a number of seconds to wait. You can't just put a 1 there. You has to be a time object, and the time object has to be time.second, and you had to import the time library now. So that was sort of annoying, but I just Googled until I found an example showing me that. That's how you do it. So that's how you express a time interval. And the dial command, you don't use just the dial command, you use the dial timeout command, which lets you specify the time. So now it will only wait 1 second. Now, since I'm expecting errors, I'd like to handle my errors a little better. So here, if the error is nil, then it's going to try to fetch the banner and show me. But if the error is not nil, then it's going to print out the error. So this is a good thing to do. And I've added this pretty much everything. Every time you do anything, check the error and else format print the error. The errors are quite informative, and that's a good thing. So it's a good habit, of course, to do error handling. All right, so I'll save that and then compile that. The same old way, just go install my project PortScan 4. And whoops, and I got to spell it better. I may have lost the G. All right. And now I got to run PortScan 4. All right. Let's just get rid of this junk. All right. And now it hit port 25 and it waited for just a second and had a timeout, and then it went on all the others. So this is not connection refused. Connection refused means it got a reset packet. Timeout means it got a handshake, but then no banner ever came. So there's this one, it was able to fetch a banner. These, the connection was refused. This was just a timeout. So now I've got my, in Wireshark, they call this open, closed, and filtered. Anyway.
Open, closed, and what?
Well, I think filtered. And here, this is actually filtered or no banner in my case. So the two are mixed together by this kind of scanner. Anyway, so now there's a flag you can find there, and now you got some challenges. There's a service on my server between 21,000 and 2130. So get its banner. Then there's port knocking. And for here, you have to do some string processing. You'll have to figure out how to take the response, and instead of just printing it on the screen, put it in a variable, and then parse the variable. Now, one thing you've already seen, by the way, is if you have a string, you can do something awesome, which you can also do in Python. Remember up here, if I read the string, it just spends a bunch of bytes, and I can just do this. I can get a substring by just putting colon, start, end. So once if you want to pick like the 15th character, you can just put 15:20. It's extremely easy to pick part of a string. So this one here, when you connect to my server, it's going to say, now connect to port here. You have 3 seconds. So you don't have enough time to do it manually. You have to write a script that will take this string. And here, let me get rid of the, this mute all button never works right. All right, anyway. So you have to find where this is, parse it out, and use it to make the next connection in the script. So it does it quickly. So when you get it right, you'll get a flag by connecting to the next port. Anyway. And then the next one is the crueler one, port knocking 2, where it actually gives you like a paragraph of text, and the port number is hidden. Here's the port number. It's the only 5-digit number in there. So you're going to have to learn to parse a text not just by the location, but you're going to have to hunt and find the numbers. Location could vary. So something like regular expressions, there's various ways to do this. Anyway, those are a couple of challenges to get you going there. And I think there's one more thing I want to show you tonight. The second one to get you going is HTTP. So you go here to go the wrong way, and that's the first one. And the next one is HTTP, which is, of course, more important. So let's talk about HTTP. I'm going to call this head 1. You probably know the TCP methods, but I intended this for people who perhaps don't. So if you don't know the TCP methods, the simplest one is head. When you send a head request to a server, you only get the header information. You do not get a whole web page. So by the way, I learned how to put more than one net. You put semicolons and you can put them all in one line here, so your code gets a little smaller. As I went through this, I learned a little more Go with each one. My Go got a little better. So this imports net, HTTP, IO utility, and format. Now, I connect to my server with HTTP head, and then I have the URL of the server. Let me make this, yeah, that's it. All right, so this will send a head request to the server. If there's an error, then print the error, then just close it. This is how you do it. Now, I'm going to print a K and V response to the header. The header response is a bunch of key values, and it's going to print all of them. for the whole, it's a structure that has key value, another key value, another key value, and this loop will go through them all and print them all with a colon in between. So it's a structured piece of data that comes from the server, and now I can print the response body if there is one, and I think there won't be any from a head request. So that's what's going on there. I save that and do this to compile it. And it's taking a while to compile, but there it is. And by the way, you'll often get compilation errors if you make any mistakes, like a missing bracket or anything, of course. All right, and so now it runs, and here's the story. This is the parameter key value. So content length is 202, varies except encoding. Notice it put brackets around this stuff, and then there's no body. So this is the header information formatted with colons in between. That's what it got. So it sent a head request to my server and saw that. It's probably worth comparing this to what Wireshark will see, because we're probably more familiar with that if you're going through our networking classes here. So if I sniff on Wireshark, this used to be irritating. Now it's gotten a lot better because nobody uses HTTP anymore. So I can just filter for HTTP and it gets quiet because the whole web is pretty much encrypted now. So this is a lot more fun than it used to be. Oh, but the problem is it's on a cloud server. I'm not going to be able to see it. Well, forget Wireshark. That's one annoying thing. Anyway, never mind. I'll skip that. That's one defect of using a cloud server. The traffic is not, in fact, passing through my machine. So we'll just go ahead. All right, so now we're going to do the get method. Now, I found something in a tutorial that is bloody awesome. If you go to this website, this is somebody, SourceForge wrote this project. What this website does is it reflects your request back to you. So you can see what your request looks like. This is my replacement for Wireshark. This is basically Wireshark for cloud servers. If you want to see what you're sending to the server, you go here and it will just show you what you sent the server, which is bloody awesome. So I sent my server, when I loaded it in this browser, I sent a GET request to the server. And here's the URL and the origin. Here's the user agent, Mozilla, and so on. Here's the host. These are the parameters my server sent. All right. So you can see those. So I'm going to use this site to test my script. So when I make a script trying to send a get to go, I'm going to send it to that page, and then we'll be able to see what got to the server. So I create a thing called get0. So I make a folder named get0, and in the get0 folder, I put get0.go. Now, here's the code, which is nice and short, just because I combined the packages in one line. So I import the same packages. Now I connect to this http bin.org/get, and if there's an error, I print it. Otherwise, I just print the response the same way we did before. So I save this and compile it the same way with go install. And then when I run it, it sends a get to the server, and now the response shows me the headers, and you can tell when I did it from my browser here, it showed me that my browser was Mozilla on a Mac, which it is. I'm using a Mac. But when I used Go, it said my user agent was Go HTTP client. That's the default. Now, you can set any user agent you want, but by default, Python libraries will identify themselves as Python, and Go will identify themselves as Go. And if you do the Splunk projects in my other class, you'll see that Splunk headers often show you this. You can tell whether someone's coming in from a browser, whether they're coming in from a script, because it'll have a user agent that tells you they're coming from Python or something. So anyway, that's the game. And this tells you the actual IP address I came from, which is, I guess, something about the whatever pathway I'm going through. This is some Google address from the Google Cloud. Anyway, so now I see a chat message coming in. Is that origin your IP or a gateway? It is, I think, a Google Cloud gateway, but it might, actually, I think I can probably see it. Let's go to my Google Cloud console, and we should be able to see that. These are very good questions. Okay, if I go to my compute engine, my public address is 35 ending in 227, and I think, yep, that's right. In fact, it's the same thing twice for some reason. I don't know why, but that is my public address from this Google Cloud machine, which is pretty nice. Now, my local address is 10, by the way, but it maps one-to-one to this outside address. So that is just the external address of my Google Cloud instance. All right, and I would move this if I could figure out what part of it to grab. This up here, maybe? All right, there we go. All right. So that's what that one does, just so you can see that we're sending what kind of request we're sending up. So now I'm going to fetch a target page. I'm going to fetch this one, target1.boundconsulting.com, one of the simple web servers I set up that just has, in fact, let's look at that in the browser first, just so you see what it looks like. That's just a page, and all it says is target server. Just a simple HTML page served over HTTP. I had to make my own because those things are not easy to find anymore. Pretty much everything is now HTTPS. So that's all that's going to do. So I'm going to make a get1 file, which is here. And I see another chat message. What percentage of cyber warriors use Mac versus Windows? Well, I imagine it depends on where you are. Out here, almost everybody uses Macs. My friends tell me in the rest of the nation, everybody uses PCs. Out here, you don't, it seems like 3/4 Macs I see everywhere. Anyway, so, all right, so let's go here. Escape Y, we'll get rid of the colors. So this is going to connect to my server. And it's just, the only thing different than the other one is it's going to use the get method instead of the head method. So instead of just asking for the headers from the server that tell you the time and what version of server software it's running, it's going to actually fetch the page. So now we're going to actually see a response body down here. Before, the body was always empty. So let's save that and compile it. And now I've got get1. So it gets the response down here. And I didn't print the header, but I printed the response. So now I've made a browser, a miserable little command line browser with no graphics. You can now fetch HTML from a server and see it with the get method. So that's fine. But what would be more fun is, of course, to hack into something. So let's have a login form. If I put in foo and bar in this little form and log in, it's going to tell me login rejected, you sent foo bar. Now this is the simplest kind of login I could imagine. It puts the username and password right up there in the URL. Now this is a terrible practice, very insecure. It's sending it without any encryption over the internet. It's putting it in the URL, so it's going to be saved in log entries and in browser favorites and all over the place. You're not supposed to send sensitive data up here. However, you can do it, and that's what I did just to get us started here. So we can make a script that will do that pretty easily. Now, small modification of the previous one, and that's, of course, why I did it. So we're moving in small steps closer to realistic login pages. So here's the code that we use to log into that server. And all it is, escape Y, is the same thing, HTTP GET, and all you do is you add the parameters up here in the URL. So there's the end of it, you just put them right there. So it's incredibly obvious. You just put them right there in URL, u equals foo, p equals bar, and it will now get a different response. So if I run this one, all I have to do is compile it with go install, and then run it with the name, which is get2. And now it says it got the answer, login rejected. So it understood me, and it echoed back, you sent foo and bar, so it understood the username and password, and it correctly rejected me, so it's working. So now I can start breaking into things. So here's a password guessing script. I'm going to use a username of Dumbo, and I'm going to go to this string, this place called login1.php. So if we go to that, I think it's the same thing. Yeah, login1.php. So I'm going to give it Dumbo, and I'm going to try various passwords until I get in. So I'm going to try Goofy, Mickey, and Dumbo. So here I've defined a username equal a string, and the colon means it will guess what I mean, so it made it a string because I put it in quotes. Here's how you make what I would call an array, but the correct term is a slice of strings, Goofy, Mickey, and Dumbo. Now I have the URL defined here, and I put the u equals there. So now when I do the get, I just take URL plus username plus ampersand p equals plus p. You can just add strings together as if they were numbers, and it will just concatenate them together. So this will just concatenate them and send it, and then I'll print the response for each one. So we will see what this does. I'm going to call it get3. So as usual, I have to define a folder and put it in the right folder. Then I put in that code and save it. And then I compile it the same way with go install get3, okay. All right, whoa, and now I run get3, and now you'll see it's a long mess. It tried to log in with Goofy, and it got login rejected. Then it tried to log in with Mickey, and it got login rejected. Then it tried to log in with Dumbo, and now it got successful, and you get a flag. So it's just trying a few things. And by the way, in case you wanted to cheat, I think you'll find you can't do it this way. If you put in Dumbo and Dumbo, it lets you in, but it doesn't show you the flag because it looks at the user agent. It will not let you see this from a browser. So there are plenty of other ways to do it. You could use Hackbar or user agent switcher and put the right user agent in your browser and get it. You know, it's not like this is very secure or hard to do, but it just shows that you're getting some control over Go. And now, the last thing is post methods. Nobody in their right mind puts sensitive parameters in the URL. What they do is they put it in the post parameters. So here's another page. If I put in foo and bar and log in, now this is going to the HTTP bin page so we can see what it does. And what happens here is it puts in the form data, it puts the password and username there. It's not just in the URL. The URL is down here someplace. Here's the URL. And it does not have U equals foo and P equals bar there. It sends it in a separate data segment so that it will be kept out of logs and out of browser favorites. This is the right way to do it. And you should be sending it over secure connection, which this is also doing. It's sending it over HTTPS. So this is a modern form, the way it really works. You use HTTPS and you put your data in the form fields. So that's what we want. That's what we were trying to get up to. So let's make the code that does that. And I see another chat message coming in. Your URL changed. Yes, in this case, I moved it to the other one so we could see it. So this time I'm going to change it here. I'm going to keep on sending it to HTTP bin post first, just so you see the request. So this is not a real login yet. It's sending the data in a secure way to the server, but instead of logging in, it's just reflecting back to me what I sent so I can test my software. It's a very good point. All right, so now I make post one, and I make source code named post one, and now I put in this stuff. So again, it's going to this HTTP bin page. So all this is going to do, this is all following what we did with the one. First, I did it in a browser, and you saw what the browser sent. Now I'm going to do it in Go, and you'll see what Go sent. So Go is going to go to the server, the same server, http://bin.org, and we'll see what Go sent the server. So I install post one, and I run post one. And now what I get, again, is a user agent showing Go HTTP client, and the same general structure, of course. It sent the username and password in the form data part of the request, and it sent less headers than a real browser would. This is generally the case. A scripting language does not bother to fill in all the headers. And that's what happened here. So this is the reply I saw there. So now I can try an actual login. So here's an actual login of foo and bar. If I go here, this goes to one of my pages. This one's not secure, but it doesn't really matter. It's login to, and again, login rejected, you sent foo bar. So this is login2.php. And so to make a script that will guess this one, make a thing called post2. And here's the script that will do the same thing as before, Goofy, Mickey, and Dumbo with the username of Dumbo. And the only difference is it's going to use post. So it's going to use this post form, and now it's going to have a thing called URL values, which is a key value pair and another key value pair. So you use these curly braces and colons and commas to separate the items. And that's what is passed instead of just putting it in the same text string as the URL, which is up here. So I put in that code and save it, and then compile it and run it. And it does the same thing. It sends Goofy and gets login rejected. and then it sends Mickey and gets login rejected here. And then it sends Dumbo and it gets login successful and a page and a flag. So that's the easy stuff. So you do that and you got it basically right. Now you've got some challenges. Here's one where the username is admin and the password is a 2-digit number. So you're going to have to loop through all possible 2-digit numbers, and you're going to have to deal with the fact that they are numbers and you have to format them as strings one way or another. And then this one here, you've got basic authentication. Now, basic authentication, if you go here, basic authentication is this garbage, where if you look at it in Wireshark, you'll see it sends a request and the server always rejects the request. And then you have to send it a request with an authentication header, which is a base 64 encoded username and password. And then it will let you in. So that's, and you'll see it's unauthorized if you don't provide the credentials. So that's basic authentication, which is a real thing that people have to cope with. Let's see if I can find my instructions somewhere. I guess I got to open it up again. I closed it by accident. All right. So you got basic authentication, and figure out how to do that. You'll find that it's easy enough to do with the libraries. And then brute force the basic authentication. Here I told you what to put in: username of admin and a password of this. So you can manually create the basic authentication header and put it in. But this one here, you make a Go script that logs into this page. And in fact, let me just show you the basic authentication. Now, this browser is running on my host machine, and it's using HTTP, so we can actually capture this one in Wireshark, and I intended to do that as demonstration. That's why I'm using HTTP, of course, which nobody else uses these days because it's too dangerous. So now, if I log into this thing with, say, foo and bar and sign in, then I can show you here how basic authentication works. So the way it works is, let me squeeze my fields so we can see it better. All right, it sent a get to the page and it got an unauthorized. Then it sent another get and it got unauthorized again. Now you can see what it sent down here. So if I right click and follow the TCP stream, okay, it sent this stuff. It sent get, and it had a host, and it had a user agent, and it had some accept encoding, but it did not have an authorization header. So it told you you're unauthorized. So you didn't have an authorization header. That's why this one failed. Now the next one was the next stream, probably 7. Yep. So I follow this one. This one has an authorization string, and that's what it looks like. Authorization basic, and then this code of base 64 encoded stuff. Now, base 64 encoding is not particularly secure or complicated, and you can do it in Python or any language you want, but for simple cases, you can just use web forms. So if I want to know what that junk is, I can just copy it and then Google for a web page that will reverse base 64 for me. So I can just do base 64 online. One way to do it, I can go here. This will decode, and so I can take base 64, that's the junk I copied out of Wireshark, and decode it, and you'll see it is foo::bar. So all it is username : password encoded with base 64, which is not encryption, it's just scrambling, and that's why basic authentication was considered really insecure and unwise. And it's a terrible technique to use, but if you put it over HTTPS, it's okay, because then it has a strong layer of encryption on top of it. The same way, if you use a VPN, you'd be okay, because even if the underlying protocol is unsafe, you have another layer of encryption on top of it. But anyway, so you can manually create the correct authentication string here if you like, because I told you the right name and password. So you could manually create that authentication string and put it in. You could even get it from Wireshark. If I go back to here, I said what the right answer is. The right answer is admin and this password. So if you could even use Wireshark, let me close this and clear this out and restart my sniffing, continue without saving, filter for HTTP again. Now, if I can log in with the right name and password. So I go here and there. Now I put in admin and p@ssw0rd, and sign in. Now, it still gave me a different message. This is lying, not authorized. If you look at Wireshark, that's just the message I put there. See, if you follow the stream here, follow TCP stream, you will see now the correct header you need, this YWR garbage. That's the base64 encoded of the correct username and password. And the basic authentication part of my server accepted it because it gave you a 200 OK. If it was unauthorized, it would have given you an error message. And then I just wrote unauthorized on the page because you didn't come in from Go. And I'm checking user agent again. So of course I could tell from the user agent that you came in from a browser. So you have to write a Go script that sends that header, and then it will have the right user agent, and then you can get it. That's all that's going on with this one. Just another little thing to do to practice with Go. And then the next one is, of course, the next logical step, brute forcing. Now the username is admin, the password is a 2-digit number, and you have to create all those base64 headers until you get in. And when you find the right 2-digit number and you come in from Go, you'll get a flag. So that's good stuff to get started with. And there's a bunch more. Then there's password hashing, Caesar cipher, XOR encryption, and I'm writing the next one, which is AES, and one after that, which is steganography. I'm going to have a bunch of these. Anyway, and they're all worth a lot of extra credit. The XOR encryption, I really went to town on. There's over 100 points of that. There's lots of fun things to do there. Anyway, so what's that? Well, yeah, they like all of them. There's a couple easy ones, and then they get harder and harder and harder. So, you know, it's intended to be, and by the way, you can check them up here. There's a CTF scoreboard. Looks like one person has started doing it. You can totally get a score up there, but if you want to get points in my classes, you have to send in the images, show with the flags. But if you're not a student here or you don't care, you can just put it on a scoreboard, or you can test your answers on the scoreboard before you turn them in. This is the live scoreboard, and I'll be doing this CTF at conferences as we go ahead. Anyway, are there any questions or anything? I saw a few come in on. So check it out, especially students that are not doing well. You can totally make up a lot of points here, and it's good for you to learn Go. You won't be sorry you learned Go. All right, question on A64, okay. A50, oh, A54, okay, good. Let me take a look. I'm glad somebody's already up to A54. A54 is the Caesar cipher. Well, let me just talk about it a bit. Let's see if the question, I might be able to answer your question, but maybe I'll demonstrate it. Could you give me a hint how to decrypt this string? Okay, A54.3. Oh, all right. Well, there's actually a lot of ways to do it. Here, maybe I'll get that far. Let's try the Caesar cipher. Since you asked, let's set up, let me go through the steps here. So in the same process, you don't need Wireshark anymore. Let's carry on. I'm all set to go here. So here's the first Caesar one, and here's the first Caesar cipher. Caesar cipher, you remember just where you move the letters forward in the alphabet by a few steps. So what this does, all it uses is the format and nothing else. Here's the plain text, ABC. And now it goes for I, C in range of plain text. I is the index of the letter I'm looking at. It's going to go 0, 1, and 2. C is the character, so it's going to be A, B, and C. Now I create a byte of C, and I add the key to it and turn it back into a string, and that's the ciphertext. That's all I did. So I created key is byte of 3. The key is 3, so I'm going to move them forward 3 steps in the alphabet. So A will become D, and B will become E, and so on. That's all it's going to do. Now I just print out the key as a number, the plain text in string and hex, and the answer in string and hex. That's all it is. It's a very simple process. So if I run this, here, compile it and run it. Run this one, and then I'll check that question I see up there. So it takes ABC and it turns it into DEF, just like it should. And in hex, that's 41, 42, 43, going to 44, 45, 46. Let's take a look at the chat message. Capture the flag, all right? Yeah, CTF is capture the flag, yeah, good. Which is the standard for this kind of puzzle. All right, so.
Are you recording still?
Yes, I think I am. Yes, that was my intention, because it's all the Go. People might want to look at the Go. All right, and so now let's encrypt this one with a key of 5, Alice. So I might as well do a solution of a couple of these as a demonstration. It won't hurt anything. So if I want to make a version of this, so I'm going to make a new file. So I'm going to go back here, and I'm going to call it Caesar 2. So I'm going to take this one and change it to 2. Now I'm going to take this one and change it to 2 in 2 places. It was something, it took me a little product. I have to make 2 in here and 2 here. So now I'm making a new file. All right, now I'm going to take this code and I want to modify it a little. So I start with this code and make it so I can read it. And now I look at what the challenge is: encrypt Alice with a key of 5. So I want this to be the plain text. So I get rid of ABC and put in Alice. And I want the key to be 5. Other than that, I can leave it all the same. So I save this and then run it. Now to run it, I need to do this go install, but I need to change the 1 to a 2. And now I run it with Caesar 2. And there you go. Alice goes to this garbage. A for B, C, D, E, F. That's forward 5. And you could just do this in your head too. You move the letters forward 5. But now I'm able to do that in Python. All right. And now I want to decrypt this one with the key. So this one has a key of 2, and I'm going to decrypt it. So what I need to do is take this string and move it backwards by 2. So that should be pretty easy. And I think I'll just use the same code again, which is not a best practice, but I don't really care. I'm done with this one. So I'm going to, all I have to do, I think, let's see if this works. All I have to do is put in the new text here, and it's going to be called plain text, but it's actually ciphertext. But I'm too lazy to change my names. And then I want to move it back by 2. I think I can just put a -2 here. Let's see if that works. That would subtract 2 instead of adding 2. Might work. We'll see what happens. So if I compile it again, the same name will do because I rewrote the same names. And okay, -2 overflows byte. You can't put 2 in a byte. Okay, so that's what you get for using unsigned variables like bytes. There is no -2 for a byte variable. So what I'm going to do is change this to 2 and then put the minus down here. That should work. Now it'll go down by the key instead of going up by the key. That looks pretty good. Let's see if that works. So compile that and run it. And yep, now it turns into a word. Okay, so that one I was able to own. Now here you want to decrypt this, and you don't know the key. You don't know what the key is. There's a general solution for this, and by the way, there are online websites that'll do it, but of course the fun thing here is to do it with Go. So I want to decrypt this text, and I do not know the key. So I'm going to highlight all that. All I have to do is modify. I can use the same code again if I don't care. I want to put that in as the plain text. And now I need to try all possible keys. So instead of setting the key equal to byte 2, I need to make a loop. Now, I had a loop in the previous one that did port scanning. So I'm just going to open that up to see an example of how to make a loop because I can never remember it. There's a loop. Okay. That's what a loop looks like. So I want to put that in here. Okay. So I want key to equal byte of 1. All right. And I guess there's no point going beyond 26. I know I'm just guessing there. There's a loop of possible keys. Now that I've determined the key, this would be key instead of I. So this will loop through a bunch of keys. Okay. And now, I think now I set the ciphertext equal to nothing, n equals 0, and I loop through it and subtract the key from it. And then I'm done. The only thing I want to do is print the answer. So what I'm going to do is make the output simpler. I'm going to put the key here. I think I'll just put the key in %d and the output as a string. And that's it. I want to make it simple because I'm going to have a whole bunch of these. So I'm going to print the key and the so-called ciphertext. There, I think this will do it. This will print the key and the answer and then loop through them all. And I think I have to have another curly brace. Yep, or one. Here's where loop starts. Here's another loop. Yep, I need a curly brace after this. Like that. I think that's right. It's not spaced exactly right. There. And I've either done it right or wrong, and the compiler will tell me. If I have the missing curly brace, it'll yell at me. So that was Caesar 2. Okay. N is declared and not used. This, by the way, is something annoying about Go. You can't have a variable you declare that you don't use, which there's probably some smart solution, but I don't know the solution, because some of these things, like it defined this thing called N, and then N equals I, and I don't think I need that thing called N. I'm just going to get rid of it. I think I only put it there because I got that error message. Let's just try getting rid of all mentions of N. I don't think I care about N. Let's see what happens. See if that works. Okay, now I is declared and not used. Where's I? I think this means wherever I used I, it should have been key. Here. No. Where's the, oh, here, I. For I, C equals range plain text. Oh, yeah. So you have to have the I, as far as I know, because it's used by the loop. So that's why I defined N. So I'm just going to say, that's why I did it here. This is because it gave me that error message, and I don't know enough Go to avoid it. I did this N colon equals I, and now I've used I, and now I just print out N for no good reason. I think I'll put it over here just to get it out of the way, because then it can't complain I'm not using N. Now there's probably somebody that knows Go can explain to me how you get around this. This keeps happening to me. Some function produces a variable I don't care about, and then I have to print it or something, or it will bust me for not using it. But anyway, there's always an annoyance in every language. Use dot dot as variable name, underscore as variable name. Oh, that's a good trick. Okay, good. I'm glad you told me. Let me try that. I think I saw somebody do that. I didn't know why they were doing that. Oh, good. I appreciate somebody actually knowing Go around here. So if I do that, that means ignore this stupid variable. Let's see if that works. That would be awesome. That would make my code a lot cleaner. Let's see what happens now. Oh, it compiled. All right. I expected another error. So now let's see what it does. Now it prints out shift by 1, shift by 2, shift by 3, and there you go. One of them works. So you just try every shift until you see the answer. That's what you do when you don't have the key. You try every possible key. So anyway, that's this one, and then there should be more challenges. That's why I'm not too worried about showing you exactly how to do some of them. Now here's another one. You have to go through 255 choices, and then you can learn how to do file I/O. And then because what you can do, I just thought of this when I was writing this stuff, I can now encrypt binary data with Caesar cipher. I've never heard of anybody doing this, but you totally can. If you look at an image, pings start with this header, .png, and then this garbage, 0D, 0A. That's what all pings start with. So if I just move them forward by a couple of bytes, it'll be unreadable. So if this is like, if I went forward by 1, so this is like 8A514F, it won't open in your browser. You won't be able to read it at all. The Caesar cipher is a perfectly fine way to scramble things and make them unreadable. So I made an image that is Caesar cipher encrypted, and you have to crack it. So I thought that was fun. Anyway, and then you learn how to do file I/O. You can read from a file and you can output to a file, and that's important. Anyway, so good. That's a start off of Go. You should all be doing a lot of Go if you want. It's good, good, clean fun. Any other questions? Aha, I see a chat message. Okay, thanks, good. And thanks for the tip about underscore. That'll make my Go less clumsy. You can see, if you care, if you go through these projects, how I wrote really bad Go, and then I learned a little bit more and a little bit more. This is how I like to learn things. This is the opposite of like organization where you take a class and really learn things. I just sort of jump to the end, try doing something, and look up tips as needed. This is sleazy, clumsy hacking The technical euphemism for this is rapid prototyping. That's the dignified way to describe this way of learning, where you just jump in and figure it out and don't worry about the details. Real programmers hate this. They said I should be fired for teaching programming in this fashion. This is the point of this programming is if you can't program at all, this will make you a lousy programmer. But if you actually want to be a good programmer, you actually have to know everything exactly and handle all the errors and everything. But this penetration testers are usually just trying to break in, and they don't need to solve all the details. Anyway, so that's the game. All right. Well, I think I'm going to stop the recording, and then I'll leave the